What's Gucci, everybody? It's AJ here again, and today I want to talk about unions. Now, we learned about enums and what can be contained in an enum. We learned about structs and how multiple things, different types, can be in a structure. And now we're going to learn about unions. Now, a union can, again, like a structure, consist of one or more member, but the compiler only allocates enough space for the largest member and only allows space basically for one member at a time. So let me just show you guys an example here. I'm going to create a union, and this is going to be similar to a structure. So I'm going to do union. I'm going to name this number. And again, I'm going to use brackets and end it with a semicolon. And I'm going to, inside this union, I'm going to have an int of I and a double of D, and this looks a lot like a structure, as you see, except for this union keyword, and I'm going to format that. And what I want to show you here is why a union is different. A union is mostly used to save memory, and basically I'm going to have this union type, union number, let's just call it go, and I'll initialize it. On the next line, I'll have go dot I is equal to 12. Now, like I said, if the structure go has two variables, but really it only has enough space to store the double, or the biggest variable, which is the double. The variables I and D are actually stored in the same memory address, and I can only store one at a time. So if I declare go of I to be 12 and then go of dot D to be 11.2, what's happening here is that I am overwriting the memory location of go.I with go.D 11.2. And so a union is a way to save memory. And it's also a way to have multiple types of something, as I will show in a second. So if you see this, basically what I'm doing is I'm saving memory and only letting the user to use maybe an int or a double, because a situation may come up where you can use either. So if I try to print out go.I right here, I need to get better at typing. Let's see what it gives me. It gives me this insane number. And as you can see, it's not 12. And let me print out go.D. Let me make this a %F, which is for printing out doubles. And I get 11.2000, which is okay. So as you can see, go.D is what is stored in the union and not the value of go.I. And if I comment out go.D and run this, well, I need to change this to %D. That's why I got 0. I should get 12. And voila, we got 12. So unions, in a union, you're only allowed to use this one of the variables at a time. You can use one or the other, and that's kind of the beauty of it. It allows you to save memory because the variables in the union are stored at the same memory location. So assigning one and then the other overwrites the oldest variable. So why are unions really cool? Well, unions can be used, as you can see, they can contain multiple types. They can use to be expressed multiple types. And let's say I wanted to make a union array, which is totally possible, just like I can make a union pointer. If I made a union array, I'm going to call it array, and let's make it 10 elements. Since it has, when I initialize this, since it has types of int and double, let me uncomment this out, or just delete it. I can make this a special array of integers and doubles. So I can make it 1, 2.1, 3.14, then 4, then 5, then 6, then 7, then let's have a 9.9, then let's have a 9,000, then let's have, I don't know, let's have a 100.1. And as you see, I have no errors and I have no type definitions because each separate index is a union, and so it's storing the 1 in I and the doubles, the integers in I and the doubles in D, and it's aligning the types correctly so I can have an array with integers and doubles, which is really cool. And that's why unions are pretty cool, is because I can be able to do that and preserve memory. I hope you guys enjoyed this tutorial, and I'll be posting this on GitHub as well, so if you could go on there, tell me what you guys think, comment below, like the video, and subscribe. I should say this every video, but yeah, I hope you guys have a great day.